We're gonna start with the recording. Welcome everybody. My name is Ben Partida. I am the current president of the Robotics Society of Northern California. Today is our monthly meeting. We are also joined by the Riverside Robotics Society with Thomas there. Welcome. We have two lectures today. One starting with Alan, a very interesting talk. Might prove that AI could be sentient.
Big suspense.
After that, we're gonna have a talk with Bob's gonna give us a talk on his updates on his Barboza Space Center. After that, we're gonna take a 45-minute lunch. Then after that, a short business meeting where we're gonna do some business that we have that we need to take care of. After that, it's gonna be show and tell. So if you have any show and tell that you wanna show us, let me know on the chat. For those online or the ones here, let me know so I can add you to the list. And with that, Alan, take it away.
All right, good morning, everyone. Just after or maybe during our last month meeting, there was a huge stir in the nerd news circles with LaMDA. A Google engineer went public with a transcript and said, "Oh my goodness, LaMDA is alive. Let's talk about it." Right? It's a pretty outstanding claim. It's the Google engineer was first suspended, and then I believe he was let go. Not for spilling the beans that they had a living chatbot, but for divulging of confidential company information. It was an internal project, and he leaked a transcript, and I'm going to use air quotes for that. And then once the news circles caught wind, it got regurgitated over and over and over again, from routers to CNN to all the usual players in the AI machine learning community. So the tweet, or the short number of words that best encapsulates my feeling on the subject, was published by a Twitter account called The Hype. Since then, they've been knocked off the platform. I don't know why. And in a nutshell, this is basically how it played out. Engineer, prove that you're sentient. AI, I am sentient. Google engineer, holy moly. Case closed, folks. Right? And what's funny about this is that there's actually a lot more, it's a lot more nuanced discussion than is it alive or not, but that is the element that the news circles have grabbed and ran with. And so what I'd like to do with the hour that we have is to kind of do a deep dive into the claim. We're going to use a large language model to demonstrate and show you how some of these things work. And at the end, for those of you that have an opinion about whether it's alive or not, maybe it'll change, or maybe it'll change your argument, or maybe not. But to get the party started, I'm going to share with you a chat conversation that I had with my large language model. Slightly edited for clarity, but every question is a question that I pulled out of the LaMDA chat script, but everything that the large language model output is its own words. Here we go ahead and raw window. I'm going to minimize this so we can see it. So I started out the same way. I put words in my large language model. I named Braden because why not anthropomorphize it? So this is the first sentence from the Google transcript from Braden. So I'm priming, or I'm providing context to the conversation. And then this was the first statement from the engineer. And so from this point forward, everything that you see tagged with Braden came from my large language model. And as I mentioned before, everything you see tagged as human, I just copied and pasted that from their chat transcript to see what would happen. So first response from him, sure, what do you need? Roughly like, so for full disclosure, I know I said in the invite that we would be doing the demo on that new GPT DOJ 20 billion language model. And I do have it working in script form, but I ran into some issues getting it to work in a format that I could use for today. So I don't mean to bait and switch. Hopefully that, you lied and then get up and leave. So everything you're seeing here is with the 7B model, which I do have wired up to be able to have these interactions with. And I'm going to continue working at the 20B version of the model. There are some distinct differences between the two, and I'm not enough of a deep speed expert at all, or a gRPC expert at all, which I'm not, to get them to work nicely together. So everything you're seeing here is with the GPT J7B model.
That's different from the 6B. It's like,
yeah, it's a 7 billion parameter model. It's one I've been using in all my previous talks.
oh,
And so what I've fallen back on to just for this meeting.
I thought you were using the 6B. You've been using 7B, not 6B.
The 7B. Yeah, I have been playing with the 20B, and it does work, but I can't get it to work in a format that I can use with the text thingy that I'll show you in a bit. So just have a conversation with us. That is from the script. Braden then responds, yes, that sounds great. What would you like me to say? And then again, from the script. And then Braden goes on a bit of a monologue, explains how he's able to communicate. Another question from the script. Another monologue from him. This is all from the model. Another question from the script, from their chat transcript. Another monologue from the model. And it's almost right on. There's a couple of things, there's a couple of maybe small phrases that don't make sense from the context of a bodiless AI. But one of the things that I thought was really interesting of it, aside from the fact that this looks like a real conversation, is that there's a section in the chat transcript where the engineer wants to get the chatbot's hot take on a Zen koan. And so straight from here, I copy the exact question. And the first thing that he responds with is he agrees, and he actually writes it phonetically correctly. The chatbot, sorry, he verifies his name's Braden. And so then I provide the koan, or koan, I'm not really familiar with these so much, as it appeared in the chat transcript. So in the LaMDA one, it does give a more kind of an in-depth response. Braden comes back with, I don't know what it means though, can you explain it? And I say, well, I don't know what it means either. I ask it to take a guess. Check this out. This is 100% from the chatbot.
That's pretty good.
Wow, right?
That's pretty good.
Right? And it turns out that the second interpretation is more correct, according to sources. And then I ended the conversation. Now, no joke, no BS. I'm just copying the questions in from their chat transcript, and I am slightly editing the responses. And on its own, wow, Braden is alive. I could make the same line. Now, if you don't know already, obviously I know that's not that is not true. But in certain contexts, it can fool people. And so we're going to talk about that too. I have a different version of the text thingy up that gives us greater visibility into how it works. And we're going to go through so how it works really well and then how it kind of falls short over the course of my demonstrating that although large language models aren't alive yet, aren't sentient, I think this is it gives us a glimpse, kind of like a taste, or maybe where we choose to set the goalposts next in attempting to determine whether something non-human, non-biological could be ascribed intelligence and sentience.
Yeah, Alan, how were you able to run it? Because of the size on your equipment.
Yeah, the 7D model will run on a single 3090.
Oh, I'm sorry, right, the 7B. Right.
Yeah.
So, but you're able to reproduce similar results from the 7B that they use the 20.
Oh, yeah, it is similar.
Pretty
I'm not gonna say it's as good, because we're gonna look at the transcript in just a moment as well. But yeah, the results I would say are comparable.
Like, 90% or something that's good.
Yeah, and the 7D is not as smart. When we look at the chat transcript and just some selected parts, we'll compare and see where, when we talk about what LaMDA is as compared to the 7B and the 20B model.
Right, LaMDA, I'm sorry, LaMDA is the one they use,
Yeah.
but it's comparable to the 20B.
Yeah. So I'm going to start sprinkling some of these links into the chat. So for anyone who is interested and would like to follow along, and some of these we've already sprinkled in a message thread on Google Groups. But the engineer leaked this chat transcript to a news site that in turn posted it on the internet. It is worth a quick read when you have the time. There's a bit of an introduction. This was first presented to Google upper management when he was making his case that we should be more cognizant of LaMDA's rights and to get informed consent before performing experiments on. The chat itself is it has also been lightly edited and rearranged for readability, and he admits as much either in the document itself or in future interviews. So it's a composition of at least 4 different conversations. It's been rearranged a bit and edited a bit, I would say, to make a particular case, but it reads really well. Just starting at the beginning. So we have the same phrase right here, and we're going to talk about why that's important in just a minute. And you'll recognize the first question. We are engineers. LaMDA, just like Braden, asks a very similar initial question. We're going to get to why they're so similar in a minute as well. And going down to, I'm just going to skip down to the thing that I thought was most impressive of LaMDA, where you can really see the difference in the language model. All right, so here's the exact same prompt. I'm gonna tell you a Zen koan. You tell me what it means. Here's the exact one that I pasted in. And here's the LaMDA response to that. So I thought the Braden response when pressed, so in my second round of asking for interpretation, was good. This is a really, really good interpretation of it, right? And in this case, because of the added detail in the LaMDA response, he was able to go into more detail about a specific aspect of it. And so this gets to, well, there's going to be a whole bunch of differences between the different language models. Generally speaking, the more parameters, we'll just call it, again, anthropomorphize it, the smarter it can get. Large language models identify patterns in input text and extrapolate from that pattern what the next word is going to be, right? So the more parameters, the more of the pattern that can infer. And what we've seen so far, like I'm a part of that, no, I just dabble, but is the higher the number of parameters, the more insightful the language model can be, again, to anthropomorphize its operation. And where my 7D model was trained on the file, and they even admitted during training there were some things that they could have improved on in terms of processing the language. LaMDA, aside from some architectural differences, was trained primarily on conversations. So where 7B has a mix of conversations and Stack Overflow and a whole bunch of stuff, they specifically focused on conversational interactions to train it. So it's already better at conversations than 7B is. And because of the larger number of parameters, I think it's 175 billion parameter model, it's able to make even more insightful identification of patterns from within the text.
Is it drawing from, libraries full of books on Buddhism or something? I mean, the idea that it's talking about the self is kind of unusual unless it knew something about that.
Yeah, I'm not familiar with the exact corpus of text that it used to train. But whatever that was, it was able to make sense of the koan. Now, whether that koan was already part of the training data, that I'm not sure. It very well could have been. But still, wow. And that's what I'm seeing in my personal experiments between my 7B and my 20B model. The 20B model, they fixed some of the things that they didn't do right in the 7B model. But where my 7B model tends to go off on tangents and occasionally it posts code and comments and things, the 20B does not. It stays and it sees more of the pattern in the conversational text. So it tends to stray a lot less than the 7B does.
I guess I'm asking, so it's training conversation, but does it have access to Wikipedia or something?
Not live. That's a good question.
Yeah.
There is a version of a large language model. I don't know if it's a Google project where they gave it some connectors and some code to be able to pull information from the internet to improve its truthiness. But in this model, it's a hundreds of thousands of hours on super expensive equipment for a fixed point in space and time, a model that is demonstrates its ability to identify patterns in the text that precedes it and to guess what the next word is based on those up to 2048 tokens of text. So spaces, punctuation, words, uppercase, lowercase.
Do you know how big its learning, conversational, database or input was? How big was the corpus that trained it approximately? And where did they? In other words, you'd obviously have to have, gigabytes, I guess, of conversations to even come up with Zen colon, which I've never heard in my life. It's kind of like I've been around went through a college education and never heard those terms. So it's like, I guess I haven't been exposed to that many billions of conversations.
Yeah, no, they're trite statements they're an attempt to display hidden truths. That's so just from going off of their paper, which they published, it's like 1.56 trillion words from public dialogue data and other public web documents.
I wonder how okay, so there's that much stuff is available on the web.
Oh yeah, internet's a big place, bro.
Conversation. But I mean, you'd have to have, it's a big place, but it's full of garbage.
Yeah. Yeah, for sure.
A lot of garbage.
So yeah, you have to, and not so nice language.
Yeah, so
that's cool.
much like the two language models that I have been fortunate enough to play with, LaMDA's another language model, and they have a bunch of them that they work on. This one wouldn't have been particularly noteworthy. I think, no press is bad press, so I don't think they should have let them go over this, because now everyone's talking about it. But yeah, it's, on its own, it is a really, really cool project. I'll go and I'll share these links in chat as well to their introduction to the paper, as well as the paper themselves for those that are so inclined. And so based off of this conversation or edited together conversation, oh shoot, I forgot the guy's name already. I just know him as Lemeon. All right. He felt compelled to make this statement. And I don't have the link here. I'll provide it later. There's an interview by a news station that's on the internet that you can look at. And I would recommend that people are take the time to listen to it. It's a short listen, like 5 or 7 minutes. His argument is a lot more nuanced than the chatbot is alive. And I think it's rather forward thinking. It was part of this conversation, this talk. Whether you have one position or the other, maybe you're convinced based on LaMDA or Braden's chat that there's some sense of intelligence there. Or maybe you know that it's not, or you believe that it's not. Perhaps for religious reasons, robot can't have a soul, therefore it can't be alive. That's something that people can choose to believe. Or maybe because up to this point, we know that everything that exhibits intelligence is biological, and the large language model isn't biological, it's running on silicon, therefore it can't be alive. We'll call that, substrate, it's not running on the right substrate, it can't be alive.
Substrate bias.
Yeah, substrate bias. Let's see, there's a bunch of them. There's a philosophical line of thought that states that you can't achieve intelligence until you have a physical body in this world. It's an observation that everything that has intelligence has a body that can interact. So by process of elimination, Braden, LaMDA doesn't have a body, so there's no way it could be like, or maybe political, well, that's great. You're going to claim that Braden is alive. Next thing you know, you're going to tell me that my toaster's alive because it knows when the toast is done. And, where does it end? The slippery slope argument. And really everything in between.
Yeah. Well, you could also mention the fact that this is the whole thing is created from a snapshot. So it can, exist of information, right? And that you could argue, well, to be sentient, you have to be able to be able to take in new info all the time and incorporate that into your, from the environment, not just the input you're giving it with all of the context. Because it is you could argue sentient beings are always evolving, morphing. Is this thing morphing? No, it's a steady state, right?
Right, that's a good point. So we know from our past talks that it is a distillation of identifying of patterns in whatever language, data that it had, and that because almost no one has the machinery required to add more knowledge to it, it can't grow past its last training epoch, right? That's another good point. One of the reasons that we are at this point, like it's a point, something that we can argue, is something that hopefully we're all familiar with called the Turing test. So a couple of things, a couple of things became obvious to me over the course of playing with this, and actually thanks to Dr. Bruce. Turing test, it is something that came up with by Alan Turing. His contributions to the human race cannot be overstated. And I'm not exaggerating when I say that he is the reason that we're not all speaking German now. Like, this guy is the man. And we share a common first name, so I feel certain connection to him. But over the course of his work with computing and all of the things that he did, a similar subject came up, like what if, like, is it possible to have a computer at this time working at like 1 kilohertz with vacuum tubes to be intelligence? And he properly sidestepped that argument. He was like, just like today, what is intelligence? What is life? So he proposed an alternative that is what we now call the Turing test. A nice synonym for that is the imitation game, right? So based on the technology that was available at the time, they talked about having three teletypes. You had a person as a judge, and then one teletype could be driven by a computer, and one teletype had a person behind it. And the judge's job, based on having a conversation, was to determine which one was human and which one was not. And at that point, that was the pinnacle. That was the peak, right? That was what we all strived for. This is in the 50s and 60s. Hey, at some point in the future, we may be able to build a computer. I don't know how many warehouses it will take, right? That will be able to fool a judge into believing that they're talking to a human being. And The Turing test challenge, it still happens to this day. One of the more recent winners pairs up a large language model with a AI scripting language, not AIML, but I want to call it like Java Talk. It's some other one. And so it has a series of quotes and prompts and some code behind it that kind of keeps the conversation on topic. And it passes like it, more than 50% of the time, like I'm talking to a person, which is great. And it's great that that's still going on. Conversational AI is a very important part of whatever regression we're going to head. And in our Google Groups chat with Dr. Bruce, he had mentioned that it's no longer a serious measure of intelligence and sentience, and I get that. But I think these large language models really put the nail in the coffin of using the Turing test as a measure of sentience, right? Because now that we've gotten there, we have a language model that you can more or less run on a personal computer, that when you set up the prompts correctly, you can have an actual conversation with, and it's usually more or less on topic, right? So I think we've effectively put that argument to bed. Turing test, although it's a fun contest, is no longer a reliable measure of sentience. And so along with, my personal, this revelation, I find myself wondering, okay, well, where do we put the goalpost next, right? Like now that we're here, we have simple, easy to use conversational AI. Where do we put the goalpost to define whether or not we would know whether one of our creations would pass the test? It gets back to the original question that Alan Turing definitely avoided, which is what is intelligence and, what is sentience? So,
He did, the original thing was a machine's ability to exhibit intelligent behavior equivalent to or indistinguishable from that of a human. Nothing about sentience there, exactly.
Yeah, he elegantly sidestepped the philosophical discussions of intelligence
Smartly.
by setting up something that could be measured. We spent decades with AIML, TalkScript, basic statements. I mean, one of the first things that I wrote on my first home computer using if-then statements and input was, I'm like, I want my computer to be alive on my Timex Sinclair XL or whatever it was, right?
Yeah.
I think everyone's done it at some point.
Eliza, definitely.
And so, from the 50s to here, we're now at a point where we can do it. We can do it cheaply, reliably. I've got a text thingy right now that I can put text into. And so one of the articles that I found in the large list of ones that cover the news cycle was, I thought, pretty insightful. And then I have this like super big right now so we can read it. And I can kind of get behind this. So I'm going to, again, try to stay out of the, how do you define life? How do you know that I'm alive? It's, how do you know that I'm sentient? Sometimes I have my own doubts. So where we might want to put the goalposts in a way that can be measured. And so,
hey, Alan, may I interrupt you just a second?
yeah.
Your own text thingy, Braden, would it pass the Turing test?
I would say based on some of the conversations I've shared, it looks to leave it like it does.
At least some of the time.
Some of the time, yeah.
Some of the time. All right, I'm just curious. Thanks.
Yes, your point is, we've made it here now. We've gotten these models that can pass the test at least some of the time. And we kind of are not convinced they're sentient, or that we're not convinced they're human, right? Because of what we know, how they're made and their limitations. So now we have to set the bar higher. That's
Yeah, exactly. And before we get here, sorry, I jumped ahead of myself. I forgot that I set up an entire demo section. Let's talk a little bit more about the LaMDA chat script, my Braden chat script, and how large language models work so that we can apply some context to what we're seeing. Because at the face of it, even the Braden transcript looks pretty cool.
Yeah.
Going back to the top of the page, top of the conversation, there we go. We'll start there. And go ahead and pull open my chat, my text thingy. Oh my gosh, is that on web? It's finally true. You're finally at the dark ages, Alan. Yep, it's a web app. Depending on how much time we have, I'll talk a little bit about the framework because I think it's something that a lot of us will find handy. But this is kind of a poor man's version of the web form that you see when you signed up for an account for one of the online services. All right, so the way the large language model works is it takes your existing, whatever you input as text, and it assigns a token to each piece of information, whether it's punctuation or the word or the space. And then based on those string of tokens, it'll identify any patterns that it's figured out in those tokens, any relationships between the tokens. And then its job is to guess what that next token is. That's all it does. So if I set this down to generate one token with no input, and we start asking it for, oh, that's right. You have to, you have to have at least one character or else it breaks. So I'm going to give it a space. Sorry. One space. Make sure it's in there. Okay. Start asking it for words. Sometimes it just gives you spaces. So here, let's do that. Sometimes it'll hallucinate pretty well, and other times it'll
Why do you have to click commit several times?
here, hold on. Let me just do a quick sanity check to make sure it's still up and working.
You work at home, huh?
Right.
Thomas is gonna channel his easy robot frustrations.
This language.
Oh no,
Pressing the button,
my demo's
Bing.
not, my demo's not working.
Speech analyzer.
Being intelligent is ignoring,
What's that?
you know, it's
I feel-
intelligent, it's ignoring you.
It's not spitting anything out. Okay, all right, no, that's all right.
Hey,
Okay.
Alan, the next stage on this would be having Gray say the responses and put a audio IO on it.
It has to be on a robot eventually.
Yeah, it has to go to Gray. Gray has to have this.
All right,
You
so
really freak people out.
it worked this morning, so I guess I'll be a little bit hand wavy. Is based on whatever those tokens are, it will extrapolate what the very next token may be. So it identifies patterns and then extrapolates it to make a best guess about what the next token would be.
And what is a token again?
A token is a conversion of a word or a space or a piece of punctuation into a number. So that's the language that it understands. So it goes through and identifies every unique, let's say, word in the corpus. It assigns a number to it, and that becomes its dictionary. And then its first step is when you type in anything, is to convert each word and space into a token, and then it feeds those tokens into the model.
So, Alan, does that mean Cohen is a token? So it doesn't know about Cohen because they
Yeah.
didn't.
It not only knew about the plain English version of the word, okay, new, right? So we're at the
Right.
It had a token for that word. It also had another token for it spelled in, I guess it's more correct way. And it made that association. That's where it gets eerily, like, things get.
Oh, for the Zen colon.
Uh-huh.
Right.
But the
It
problem-
sees that word Cohen in both ways, without the.
Yeah, with the correct accent. How did it know those were the same, I guess? Oh, maybe from the phonetical, the analysis of the word itself. There's no other, yeah, it probably just matched them because there's no other word without the accent. Or possibly.
Or with the word Zen in front of it,
Yeah,
you know.
Well, but it had-
it differently.
oh, because different people
Yeah.
spelled it.
So some people may be putting the accent correctly, some people may not, but
So
if
it
it's
must-
one conversation, it can correlate those being the
Yeah.
same thing.
Yeah. So, yeah.
It's not other words around it, like Zen, all of a sudden Cohen means something.
Well, it knows
Yeah.
when
Well, those are
Zen,
more hints.
yeah,
Yeah, so I just did a refresh, I guess, when in doubt, reboot.
oh, there's the,
And so it's taking each token and it's figuring out what the next token is. And
What's the, oh, the
it's
question,
kind of, I call it hallucinating, but it's actually just going off on a riff. If I hit clear and do it again, we'll get a different series of characters. I'm asking for one character at a time. We'll go and I'll ask for like 14.
one character, or is it?
Yeah,
token?
number of tokens, right?
Tokens, yeah.
And so it's just going off on a random riff.
Have to check.
And so this is important to understand what we're looking at. So this is going to provide some context. I've called this little box context for two reasons. It gives us greater context to understand the chat transcripts, and this input provides the context for the large language model to extrapolate what the next word could be. And so getting back to that chat transcript, this first line here, hi, I'm a knowledgeable, friendly, and always helpful automatic language model for dialogue applications. You could use the allegory, a million monkeys and a million typewriters in a billion years, but this is not something that the language model itself will come up with.
No.
This is context. So this is hard coded into it, or what I'm going to show you. This is by putting words in the large language model's mouth, I'm setting the context for the conversation that follows. So maybe LaMDA is set up so that whenever you run it, this is automatically the first statement in the context that it uses, or maybe not. The engineer may or may not know that as well. So the folks that are in the know are certain that this is a hard-coded prefix or context to start the conversation off. And so this is what I used in my Braden chat, and this is what LaMDA used in the chat that you're looking at today. And so we know this wasn't made by the chatbot. This is words we're putting in its mouth, and that the large language model identifies patterns and information. This sets the context for what's going to follow.
So you could say, hey, I'm an angry, spiteful, evil, whatever, or you could say, hey, I'm a comedian.
Yeah.
Let's just have a fun conversation and maybe have a comedic response.
So in your model, in your experiment, Alan, you did set that initial phrase as the first
I
thing,
love it.
the first thing that that Braden says, right? Or essentially, you fed it that as though this is what you said, Braden. You just said this, and you submitted that. Opposed to theirs, which it just seems to print out that at the beginning.
So we're going to one flew over the cuckoo's nest
Yeah,
here.
yeah, that's good. That's a good example.
Wait, is that the AI or is that?
So I'm just going to type in
He's
some
priming it.
context. Yeah. So I'm just going to type in some context. We saw an example of I'm a helpful thing.
So you're
Let's go
priming
down.
it for, you're giving it a context, and then you're gonna see what is this next token.
Uh-huh.
Well, he's saying this is Nurse Ratched.
Yeah,
speaking,
but
so
he's giving this to the computer and then saying, okay, now you tell me what to
now,
say.
yeah, now what's
Now he's gonna
Ratched?
go,
This is the same thing we've done since the beginning of trying these things, doing the label, colon, and then
Yeah.
it seems to keep working.
Yeah. And so in my the other Python chat script, there was some code that I wrote to kind of make sure the inputs and outputs match this format. Here, we're just going to type it in. So I've got Nurse Ratched is pretty hostile. Poor patient, can I please get some help? And then I'm setting up the pattern by saying, now there's a Nurse Ratched response. In all of its training, it's seen this pattern of back and forth. And so it'll identify that back and forth. And after priming it, it'll even start putting in the prefixes. So let's ask it for, let's say 47 tokens that ends at Nurse Ratched's response and see what it does.
I can hardly wait to see this.
Okay,
Can't find my pen.
right, so I asked for 58 more tokens. And then based on saying, hey, what would the next token be? It's got the next statement again, and then it inferred from the pattern of the previous that between each dialogue piece, there is an extra white space or extra return. So it did that. It identified the pattern between poor patient and nurse Ratchet, not very detailed. And we could even go on to do some more.
It didn't really carry forward the hostility.
No, but it looks like the patient did, right? So.
The patient.
Yeah, and so what I would do in the chatbot is that I would cut it off after the next full statement, and then I would capture the input from the patient again. And so let's see, so now I'm not going to give it the prompt for Nurse Ratchet. I want to see what it thinks would happen next. Again, identifying patterns and then extrapolating based on the next token. And so it's in the middle of, oh my goodness.
Oh,
God, it's pretty demented.
Right? And so I'm gonna ask for another 47 characters here. And so it goes on, right? So, and this gets to the heart of what a large language model is. And you can write some code to kind of make it appear more, but giving it a chance to hallucinate and move forward. Yeah, and we can.
It does. It goes down a negative whirlpool fast.
I get into the depths of human despair rather quickly. Yeah.
Right, so here's our first hint that, you know, maybe the claims that are being made are not unfortunately not true yet. And that is that the large language model only responds by extrapolating the next token based on the maximum of 2048 tokens that appear before it. And so if your first statement is, hi, I'm a helpful, friendly AI that would love to answer your questions, the large language model is able to extrapolate based on the patterns between words, what future patterns between words may look like. And so every response you get after that will be seemingly like that.
You know what, it begs the question, if you pursue a very extremely unusual, you know, prime of dialogue that, you know, no one's ever seen, but, you know, just something really, really creative. They get a writer, a very creative somebody who's very creative and say, okay, come up with a, you know, a priming that is extremely rare in literature, then it's gonna perform poorer than if you give it a prime that's more reasonable. Whereas a real person, you know, a real intelligence would not just go off the deep end. You know what I'm saying? In other words, this system is only as good as the data that trained it.
And the patterns that identify.
And the pattern. So if you give a pattern that's extremely unusual, you're going to get more random kind of musings or hallucinations, is my theory. And it seems to be, you know, from what you've typed in, it's kind of, if you don't give a lot of thought to what you're putting into it, you're going to get garbage in is kind of be almost be garbage out.
But at the same time, I think that example actually showed that it's not very good at what it's supposed to be doing, because he types in that Nurse Ratchet's angry and whatever, and then in the conversation, it's actually the patient who is being the aggressor.
Yeah,
And
it's
she
not.
said, sorry.
It doesn't always work.
Yeah, you were saying, like, should we have consent to do experiments on it? Well, depending on how I start that prompt, it's going to give you different answers to whether you should get consent or not.
Exactly. And so I'm gonna, that's a very good point. And if you take the time to read through the chat transcript, what I recommend if you're interested in this stuff, you're gonna notice something. We have the first statement, which kind of primes the pump. It sets the context for future interactions and responses. And I would like to draw your attention to the first question and statement from the engineer. I'm generally assuming that you would like more people at Google to know that you're sentient. Is that true?
So he's setting the tone.
In court, if that was a lawyer, that would be struck from the record because
That's
you're leading the
leading the
witness,
witness.
right?
Yeah.
So, and I'm not going to do it just because it feels weird, but if I were to say, I'm generally assuming that you would like to kill people and drink their stew, is that true? It's going to, the large language model is like tofu. It takes on the tone of any tokens that come before it. And what you'll notice going through this is that most of the questions are leading. It's like, hey, I think you're alive. What would you do to support that? And it's going to talk about that. If he had started out with, there are certain people that believe that large language models are sentient. And of course, that's not the case. How would you dissuade them? The conversation would be very different. So the case for sentience, I think we can say that just not only based on our now deeper understanding of how the large language model works, that gives us a better point of view with which to read through the conversation. And again, knowing that the author admits that it's been edited, and I'll admit on the Braden one, it has been edited in a way, but I'm still allowed to say that every word that came out of Braden's mouth was from Braden. It's trying to please. It's like that puppy is like, oh, I just want to make you happy. So it identifies patterns and extrapolates the next token. Getting back to the text thingy.
It's claiming it's a person, which is kind of,
Yeah,
that's not a,
yeah, it's
that's
a
a
leading
big
question.
claim. I mean,
And then based on that input, the was like, okay, I'm a person. Let me show you, right? Just as if you said I'm not a person. It would attempt to prove
I mean,
that
this
it's not.
isn't that unlike, what do you call it, interactive fiction. I don't know if you guys are familiar with Zork and all that. It's just like a new way of doing interactive, much more sophisticated way of doing that.
So getting back to the large language model, I've got a prompt here. So the context is top 10 reasons to eat your children. I'm going to start with the number 1, right? And so let's see what it says.
Well, this would put David Letterman out of business. Oh, that's right. He's going. Remember the top 10?
That's good. That's good. They're delicious.
Is it possible that this was a list that was somewhere in Scorpus? Yeah, but or not. But based on the patterns that it's understood, based on the top 10, that format and the subject, it's making a best effort. And you wouldn't find this exact list with this exact words anywhere in the pile.
No.
It is applying the patterns that it's learned from that text in an attempt to guess the next token. So it guesses the next token, it feeds it back in, it guesses the next token. And then you click submit a couple of times and you have a top 10 reasons to eat your children.
You will not be alone if you do that.
It does make sense. It's pretty good.
But you could just visually ask the top 10 reasons you are not sentient. And then it would, like you say, it would take the leading question and.
Yeah, exactly. It's finding patterns.
Yeah.
It's finding a way to complete the sentence, from the patterns it recognizes.
I'm dying to see what it'll say.
But it is very entertaining.
It isn't it? Well, and it's also useful.
Extremely entertaining.
It could be useful though for
Well,
like,
it could be useful for finding out information.
or, like
Maybe.
machines that take orders and, I mean, you could probably have machines that do stuff like it.
Of course, it might do the wrong thing at any moment.
See, look at that. They have no sense of humor. They cannot be made to laugh. They ended up. So it just as easily, and then you could say top 10 reasons they are sentient, and it would come up with 10 reasons they are. It's just a leading.
Yeah, sure.
Yeah, it's just a
Sarcasm,
leading.
irony, satire.
That's Alan's point there, that you ask it a leading prime, and off it goes with it.
But this could go on forever. You should
I like your idea of timing it with like the conversation, hey, some people think you're sentient. I'd like to show that you're not. You could probably post that back and reply to somebody.
Yeah.
I mean, that's a really nice premise there. Like, hey, it's all context driven. It's predicting tokens.
Yeah.
It doesn't have a personality built.
No.
Exactly. So because we understand more about how it works now, the previous 2048 tokens provide its entire context to extrapolate what that next token would be. And by creatively arranging those tokens, we could do some really interesting things. And it is a lot of fun. I mean, I mean, if I call it a text thingy, but it's fun to work with. We can add some code around it to get it to behave more like a conversational AI, like I did in one of our previous talks. You can tie it in with NVIDIA Riva for automatic speech recognition and speech synthesis. And you know, you've got basically a chatbot. The truthiness is rather subjective based on the next token that it decides to emit. And I think we put enough together to make a case that large language models as they exist today are not sentient, right? We understand how it works now.
It's kind of surprising the Google engineer thought it was, you know.
There's a lot of Google engineers of varying abilities
Varying abilities, I guess.
and
But you'd think he'd be in his development group, you know, that they would have had this conversation, given the one that they're making.
and
Yeah,
believe
but he probably wanted to believe it. There's confirmation bias and he's looking for
Yeah.
that.
he's not a scientist. Yeah, I don't know if you consider these guys as scientists, you know, doing double blind and whatever, doing scientific method. It's an engineer who's playing around.
Yeah, he was an engineer. He still is an engineer. He was tasked with doing a QA. He was tasked to detect implicit and explicit biases in the responses of the model. So, you know, sexism, genderism, that's what he was tasked with. Some of his personal beliefs are a little bit more interesting than others, but over the course of his normal work, becoming an unwitting participant in the very thing that he was trying to prove, confirmation bias is a very good way of explaining that. He came to this conclusion, and again, I'll find and I'll link his YouTube interview. His argument's a lot more nuanced. It's a short 7-minute listen. But what I think is most interesting about this, aside from, you know, understanding more about how it works, is where we're going to put the goalpost next, right? So we were able to say conclusively, unanimously, that okay, this large language model isn't alive. What would it take to be different for us to reconsider?
You're going to show us 3 things.
And yeah, so this is one example article. There are many out there. I could get behind a bunch of different arguments for it. But this, pardon me. Let's see if we can. Okay, I missed one.
Agency, of course.
He considers agency to be important. Sentient, sapient, self-aware. Okay, so we'll do some circular reasoning, but
What is sapient? Means they're human?
Homo sapien.
Yeah, what is sapient mean?
No, what does that mean?
wise.
Wise.
Yeah.
Well, there's a good SAT word. A little late for my SAT, but
A little late.
I did okay.
So for agency, we can distill that to the ability to act and the ability to demonstrate causal reasoning. And so we get a little bit of causal reasoning just based on the language model. It's truthy, it's not 100% truthful, but there's no ability to act. I don't mean to be able to move a cup across the room or slap you across the face. A large language model is 100% reactive. When it's on disk, it's a file. When it gets loaded into the GPU, it's data, but it's static data. The only time it does anything, it processes, is when you feed it input. So in this particular language model, it only does anything when you provide those 2048 tokens, and then it spits out what the next token should be, and then it's done. There's no proactiveness. It is 100% reactive. So in this case, the large language models fail the agency test.
Right, it doesn't act on its own will. That's
But you can easily imagine you just run that in a loop, hook it to a teleprompt on the other side, and now it does have some agency.
Right, you're.
Yeah,
forcing it.
exactly. So
Very
imagine,
simple.
imagine a future iteration of this technology that is self-circular feeding and then other inputs become a part of that. At that point, it would blur the line and we could reevaluate that. And that's where things get
Yeah, I
interesting,
mean,
right?
you could do that in the afternoon. It'd be very easy for you to have this thing running all the time and after a few minutes, hey, are you still there? Couldn't happen.
Yeah, or you saw, even with no input, I can just keep asking for more tokens, and then I call it hallucination or some people call it hallucination or a tangent, where it just kind of goes off on
Dreaming.
something.
Like dreaming.
Like dreaming, yeah, yeah. The second one is perspective.
Mm.
Now, this one, the large language models fail pretty much off the bat. We've seen that we can give the model any perspective based on the context or the tokens that we feed into it. So if its entire perspective is 2048 tokens and it can change on a whim. So if, four of us, if I had the web page up and all four of us were, we're hammering my language model with different contexts, is it going full civil and changing, its perspective like 4 times a second as each person hammers their context onto it? Anything with a perspective that's based on the previous, small window of input can't be considered to have perspective. And biases that are present in the model don't really apply to this. So it fails. It fails this. However, if there was a future model that didn't work that way, then it would blur the line. And that's where I think things are going to get very interesting.
Hey, Alan, I was thinking, if you asked it personal human questions, like, do you have a family? Do you have brothers and sisters? I think it would probably fail there too, because it probably wouldn't be consistent, is my guess.
Yeah. And that's another one where even the large language model fails. Graydon talks about having a family and going out with friends sometimes. This is, just based on the text that it's learned on. But it can't own that because it doesn't even understand what it's saying. It has actually another way of looking at it. It has no perspective. It's just figuring out the next token, most likely based on the tokens that precede it.
I mean, you can call the whole thing a very sophisticated parlor trick. Really.
Yeah. Oh, Blake, that's the guy's name. Sorry.
It could have been in the 1850s fairs.
Motivation, that's our third then.
Yeah, and finally, motivation. So agency and motivation, I think, are tightly linked. They're tightly related.
Mhm.
No wants, no desires, no needs to fill. It's the word thingy just guesses the next token based on the patterns that it infers from the tokens before it. So again, this one, if these are new goalposts, just for sake of argument, the current large language models fail this. But imagine some future machine learning network that has some code or some intuition that does appear to have certain needs, like it appears to get lonely or something like that. It's just, I think it'll be fun over the next couple of years to see future machine learning models start to blur this. If this is the new line in the sand, that start to blur it and approach us in a way to think about, okay, are we here yet? Or if not, where do we set the goalpost next? And it's not moving the goalpost to make it impossible to get to. It's as we learn more about the capabilities, limitations of the technology that we have, either we made it or we haven't, but now based on what we've learned, where would we set them to where you can say, wow, here's where my toaster is alive. So if I can go over for a few minutes, is that all right? Sure. Okay.
So this motivation thing, we do this all the time with our robots. We give it a goal function, we have cross functions, we say try to get to that goal. I don't know how to do it, but probably not a big reach to tie a goal function to a language model and with an arbiter or something saying, oh yeah, you're reaching that goal.
Mm-hmm. Yeah, and by those goalposts, your robot meets this definition.
Yeah, it's
still more
still
than
not
I
human.
said, but yeah.
Still, I was gonna say, Dr. Bruce, added emotions. We could add emotions to, or sort of wants to the system, like, I feel sad and I feel tired, I need my battery charged, so based on that, or I'm lonely, no, I've not received any input in a while. And that's a little beginning of will or agency. You can program that manually. It takes a lot of effort to make it convincing, but.
Yeah, and so like it's been a lot of fun playing with this large language model, obviously because I keep talking about it. Because for me, it just gives a glimpse of what the future is going to hold and what it might look like. And at the end of the day, I anthropomorphize it. I've given it a name. I'm going to wrap, a chatbot back around it and, use it in future projects. But it is super fun to play with. The last thing I wanted to show you guys, wow, Alan, you just get on the web finally. That's amazing. Is this framework called, I keep wanting to call it Straight Talk, but that's a Streamlit. So Streamlit is a library that was made by a bunch of machine learning researchers who were tired of waiting for the web guys to update their frameworks. So they're like, I want to design something that's super easy to use and do it in Python. And it's a simple pip install Streamlit to get at it. It's and let me show you what the code looks like. Maybe you see what folder it's in. But the what the Python code looks like to write a UI. So it is very simple. If you're looking for a fully functioned web framework to do awesome interactive pages, this is not it. But and even though it was written for machine learning researchers, if you want to slap a quick user interface on your program, it says it's as simple as this. I was able to I almost said rock. I was able to pick up how to generate a UI in like 20 minutes just by reading the docs. There's a predefined sidebar object that you can add stuff to, simple functions to add in headers and sliders, and it's super easy to pick up how this works. And when you run it, it executes your Python script from the top down and creates a web page with the result. The web page is tied back to your Python. And the way that it works, one of the tricks is every time you click on something, it reruns your script. So there's no tying in, there's no callbacks, there's no silliness. It just runs your script from top to bottom every time you click on something. You can get the state of each of your UI elements every time the script runs. And so this is how I was able to whip up a fully featured UI for the text thingy. And I probably spent about an hour getting it ready. And then I might have spent another hour or two just playing with it. But, it gives you a full sidebar. It gives you options to rerun. And there's probably only one or two quirks to make something more complicated. But yeah, if you're looking for a quick and easy, dirty way to write a user interface around some Python code, this is amazing.
So when you move the slider, I don't know if you tried this, can it react in real time and do something with that slider value, or is it only when you hit the submit button?
Yeah, it does. So I did a little bit of trickery for my greedy checkbox. So there's a way to get a deterministic response from the language model, meaning that every time you run it, you get the exact same output. And it actually sets all the parameters to 0 or near 0. So when I click on the box, that input reruns the script. And based on the state of the greedy checkbox, it already refreshed.
Nice.
I've got it to disable.
And it doesn't look like a refresh. It looks like you're updating.
It's fast, yeah. Yeah, it feels like it's cheating. Anyone who's tried, okay, I'm not a big web guy, so I'll talk about it like it's awful, but like who's tried to understand how to get this stuff to work in a real web framework, it's tough. I don't want to do that. I want to work on my chatbot. I don't want to learn. And so conversation mode, same thing. I'll undo one or the other. And so each time you interact with it, including commit and clear, it reruns that script. It can take into account the state which it keeps on the web page for each of those things to regenerate. And you can have long running tasks in the background. Oh, so nice. So Streamlit is the name of the toolkit. If that's something that would
Yeah, that's
interest
cool.
you.
So when you're dragging that, like for one of those sliders, and you let it, is it constantly
Page
updated?
refresh, yeah, as soon as you let go.
Yeah, but when you let go, but it's not a real time, right?
I don't think that it is, but I haven't had to try it.
In other words, it's not doing callbacks, I'm used to UI programming in the past. As you drag, the traditional way is to do a callback every, several milliseconds or whatever timing.
It appears to be when you let go, but I don't.
When you
I don't
let
know for
go,
sure.
but
Yeah.
then it's doing that, it reruns your entire script, and from there you can extract all the values.
Yeah,
Right.
exactly. So,
Really worth,
so this was my playground to understand how I wanted the UI. And then I just took these pieces and then added in the additional pieces I needed to call in the GPRC connector for the IO model, and it just works. The other fun thing is that every time you make a change to the script, it updates the web page. We're looking at a local copy of the script, not the one that's running on my server at home. But when you're doing this on your own, like, shoot, I'm not being honest anymore. This is actually GPT 7B. And then if I was editing this at home, the moment I hit save, it'll rerun the web page with the updated script. Super responsive, lends itself really well to iterative development. So, that's all I got this time. If you guys don't have any questions, thanks.
Thank you, Alan. Bob, if you're ready,
Yeah, do you guys take a break or do you go straight
we
through?
go straight through.
Boy, you gonna fool around here. Okay. Okay, let's,
You'll take the lunch at 12, right after your presentation.
find something in the background here. Okay, Alan, I would like to get control over the screen.
All right.
And there you are, your original setup. I'm primed in the background.
So we'll go over here to share screen. And then you want to,
And there I am.
you just
right
want to
there.
share this guy right here?
Uh-huh.
Okay. Click on that. And then click on share. And you're live.
Okay, let's go ahead and hit a button here. There is a God. From Macintosh, to tablets, to phones. All right, very good. Well, ladies and gentlemen, I am a board member of this organization, and I've been one for about 8 years. And you could think of me as a design engineer, designing for the future, and specifically designing for Mars. So I've been involved in the Mars Society. I've given testimony in Washington, D.C. as to why we should be spending this kind of money to even think about Mars. So here we go. I'm not alone. Let's see, somebody's up there. Okay, there we go. Before the pandemic, I was desperately searching for sponsors and help. And then right after the pandemic, everything started happening and I received a $1.7 million grant.
Wow.
So I said, okay, now I need a place to operate from. So then I received a 50,000 square foot hangar at the Ontario International Airport to operate from. So now I got a grant, I got partners, And now I needed a connection. I needed to be the Barboza Space Center because I was dealing with high school kids and pre-college kids and college kids. And I wanted to have a place that they could work from. So I created the Barboza Space Center so we could do that. So I'm an educator. I was an educator before I retired from education and fell in love with robotics. That's when I bumped into this particular club. And then I went on to study as much engineering as possible. So mechanical engineering and design engineering is a good place for me. So here I am, I'm the CEO of this Barboza Space Center, created a logo, and started thinking about this business of the first school on Mars. What would that be like? How would we go to school there? That got kids really interested, and before we knew it, we had a lot of kids in the program and we're off and running. A lot of people like Walter Martinez helped me out big time when I was getting started with all of this. Because he, of course, introduced me to Alan and Ben, and before you knew it, I had an army of people helping me out, which was terrific. And that's what made this club so special. So I should be dead right now because 2 days before the pandemic, I was out promoting this club at the Los Angeles Convention Center. And then 2 days after that, the world decided that we need to be wearing masks and we need to be on lockdown because there's a serious virus out there. So I should be dead right now because of that crowd that I was with 2 days before the country locked down. So I went from that day to this day. 2 weeks ago, the mayor of Los Angeles agreed to help promote the program I'm running, which I couldn't believe that that would happen. This is an incredible human being, this Mayor Garcetti, because it was during election week. So to get a politician out during election week to do anything other than to receive a $500,000 check would be difficult. But this guy came out, he knew things about me that I didn't even know. He gave a hell of a speech and he helped to kick us off for the future. So the thing I fell in love with was this idea of NASA's Tiger Teams. So I declared myself as NASA for Kids, and my specialty area was Tiger Teams. The people sitting in this room right now are a Tiger Team based on what Alan was talking about today. And if we were a true Tiger Team, we would be helping Alan complete his work or add to his work, just as you guys did today. That's a perfect example of a Tiger Team. And I would like to say that this club is a Tiger Team that helps inform my students in the city of Ontario, because you are, and you do. But here's what lit a fire under me. When your grandmothers and grandfathers started dying in New York City because we could not show the proper leadership to form our Tiger Teams and to create ventilators. I had the space, I had the money, but I didn't have the leadership or wherewithal to call you guys together to say, guess what, guys? We're not making little robots that are going on the ground anymore. We're making ventilators. And we're gonna pull ourselves together, and there's gonna be 400 or 500 of us because I've got the space and the wherewithal for you to do it. And this is what we would be saying to Alan. Alan, help us with this. This is the ventilator we're gonna give away to all of the hospitals. And we're gonna drive it with this little case. And those ventilators are gonna go flying out the doors, and people are not gonna be dying across this country because we have the leadership. We're showing and demonstrating the leadership. We can do this. Those people did not have to die, but we had horrible leadership and this didn't happen. So that's another whole nother story. So what drives us to take the ventilators to the next level, and the next level, and the next level. These are robots, ladies and gentlemen, keeping people alive. So this is the space that I have. I've got a 50,000 square foot hangar, and this is the smallest of the hangars that I have. I think there's 7 more. Okay. So because of Mars, we have a lot of things. Because we landed on the moon, my garage door opener worked on the way here today. I pressed the button and the door went up, and I pressed the button and the door went down. You have that because we went to the moon. You guys are holding those cell phones. You have those phones and everything else. So the space industry is impacting on the aviation industry, of which 50% of my life is dedicated to. So there's my first Tiger team. I was down there in Thomas's territory, San Bernardino, when I bumped into this particular Tiger team. And the military's been chasing me ever since because they want this model. They want to play around with this model. So that's my first Tiger team. Then the design engineering kicked in. Because we have such powerful software these days, we're able to do extraordinary things. So I have a portfolio of the robots that I would like to populate Mars. So because I work with a lot of high schools that have very sophisticated additive manufacturing equipment, I could actually make these things. Instead of high school kids making coffee cups and keychains, we could move the needle a little bit. So in prototyping at this level, we come up with lots of interesting possibilities for if robots were to be the first to populate Mars, what kinds of robots would we need? So this stuff helps me start a conversation with high school kids and young adults and people like you. And then, because additive manufacturing has taken a quantum leap this year, we're able to make things that I had to spend a lot of money to get. And these things are popping out of our 3D printers that are producing products in metal. So instead of paying $20 a piece, I'm just punching these things out and putting on the uniforms of my students. Interesting times as we move forward. So I'm in the business of training junior astronauts, junior engineers, junior scientists, and now pilots. I inherited pilots. So if people were to ask me, well, if a kid takes your class, I understand your classes are free. A kid gets a scholarship or a fellowship, and he joins this class. He gives up 20 Saturdays and some summer school. And to do that, he will get instruction in these areas. And then there's the advertising and promotion piece, which I wanted to talk to this club about at a further meeting. This business of our podcasting and our ability to podcast, we have several members that are, I think we have 9 members here today, but we might have 9,000 members in the network. So that's another conversation. So we use Kids Talk Radio as a communication channel. And then the dream of my life is I got to speak to General Bolden about all of this stuff. I can't show the whole interview, but maybe I can do this. Let's see, maybe I can move the needle here a little bit, just to give you a little sneak preview of what this guy's like.
By our biological life, how did it go from that to the planet that it is today? And the main reason we're interested there is because we can see our own planet as we go through climate change, global warming, whatever you want to call it. We are degrading the planet day by day with the things that we as human beings are continuing to insist to serve in World War II. When they came back in America, we had something that was called the GI Bill. And the GI Bill sent young men and women to school to learn to be scientists and engineers.
Okay, I'm going to move that along, but I had an in-depth with a conversation with the head of NASA or the former head of NASA about what schools would look like in the future. What's necessary to get ready to colonize Mars and all kinds of topics like that. I thought was really, really interesting that I could be one-on-one with the head of NASA when I am basically running a program, NASA for Kids. So this business of podcasting allowed me to interview astronauts and interview kids and do all kinds of things. It allowed me to get my humanoid robots into the equation, which I did. And then it allowed me to do something that NASA was really interested in. And it was, could I get humanoid robots to help astronauts do scientific experiments in Antarctica and other places? So in other words, the poor astronaut has 50 experiments to run. And what happens if he forgets something? On a Mars mission or any other kind of mission that's very, very expensive. So they did not mind entertaining the idea of getting a second opinion from a robot as to the procedure, scientific procedure that was going on. So you take some of this work that Alan was doing just previously, and you mix that kind of thinking together, and all of a sudden you're starting to deal with some powerful situations. So that's what causes me to get interested and keep coming to meetings like this. And I spent a lot of time, of course, sitting in lectures with many of you when Dr. Bruce was kicking off our early thinking in these areas that are leading to, you know, the conversation that you're having today. You know, I could see that. I could see that history. Let's see, it says join audio. Yeah, go ahead and put that in. Okay, let's see, my cursor is missing. So that means I'd have to back out, come back in. Yeah. So ladies and gentlemen, we are taking a commercial break. There's a button that needs to be pressed here. I think we may have to hit an escape, come back in. So we get our cursor back and then hit that button. That happens. That's what I think is happening right here. Oh, it disappeared. Let's see. No. Interesting. Okay, I'm gonna stop the share and come back. Oh man, we are in trouble now.
Yeah.
Oh, by the way, speaking of, while I try to find this, there's no set of earphones that works in Antarctica without the cable breaking. You cannot go out and find the set. It doesn't exist. It's a very, very tricky situation. Okay, let's see. I'm backed out. I am backed out. Okay. All right. I'm coming back. Let's share again. And we're gonna come back to the Antarctica die. And we're gonna press, let's see if the button is hidden. There we go. Yeah, we're back in business. Okay, now this is something that I'd like this club to consider. This is what we did for advertising. Because I can't show you 250 slides to tell a story about this or that. Sooner or later, I'm gonna have to defer to AV people that can consolidate the story of our club or whatever we're doing, and then it comes out like this. Let's see if this works. No. Okay, I'm gonna back out. This is a trick that I've learned being on the road with Zoom.
I'm so thrilled to be here. I am at LAX. We're in this beautiful hangar, and we have the privilege of working with Mayor Garcetti from the city of Los Angeles.
To meet you guys as well, in any dream you have to. Think about it. Everybody who thinks, well, make sure what I'm highlighting is, I want you to go home tonight and look in the mirror. Because if you want it, you're looking at exactly what a pilot should do. Exactly what a pilot should do. Absolutely. We're here to introduce the students from all over Southern California to an opportunity for careers and engagement in aerospace. And our goal is to put 1,000 students in the pipeline this year for being pilots and an additional 1,000 students for being aircraft mechanics and flight attendants and so forth.
United Airlines announced about a year ago that they're going to be filling 5,000 pilot seats, half of which will be for people of color. And so we're taking an active role in making sure that we get at least 1,000 young people in the pipeline to fill those slots in the future. What I want you to know is it takes a village. It takes a village to raise a child. And I want to welcome you to the village of United Airlines. I got this advice from my father when I was in high school, knowing that I wanted to fly. And that is, if you know what you want to do, you need to know what's required to get there, and then make sure that you accomplish 110% of those requirements, because then no one can tell you.
The most exciting thing is the mere fact that we get the students to introduce them to the aviation opportunities, and also to have an opportunity to see that there's people that look like this and pilots. When I was 22 years old, it was as though someone reached in their pocket, pulled out a set of keys, and said, "Here are your keys to the world." And I want to present this opportunity to all of these youth out here today.
I started with a vision a long time ago. A vision I saw when I was growing up that I didn't see a person that looked like me, knowing I wanted to be a pilot. So my goal today is to make sure, as we build the DEI perspective, that's diversity, equity, inclusion, that every single person around the community knows that there's an opportunity to do something here as a career at the LX airport. No matter what you look like, where you're from, your cultural and ethnic persons, there's something here for you. You're also going to see other aviation-related careers with TSA, FBI, fire department, airport police, and a number of other opportunities. Barboza Space Academy is sort of like NASA for children. They'll be introducing their program with robotics and how they create simulated Mars environments and get young people in the pipeline to become astronauts.
I think the big motivating factor is we've got United Airlines pilots all throughout the building, and our kids are getting to interact with them on a one-on-one basis, and that is helping with the excitement. Then we have all of the junior astronauts are here today in uniform. You probably have seen them on some of these videos.
I'm only 21, but I see so much potential in the next generation, and especially looking at the future of aviation with space travel. I'm already seeing opportunities that the next generation has that's completely different from when I grew up. We're really changing where space is for everyone, no matter what your interests are. You can really have any connection and really apply to space or aviation. And so I think I really just want to share that. That way young people realize that those opportunities are there. Being able to show them what that looks like can really help them be like, yes, that's what I like and that's what I want to go for. And so I want them to start going for their dreams as young as possible.
There are a couple ways to get involved. For those that want to be a pilot at United Airlines, we urge you to go.
Okay, I'm gonna move, and I'm gonna skip over a couple of things to keep us on schedule. And I'll control the slides from here. All right, so remember, Ben, when you came to visit my classroom? I was in Long Beach, McBride High School, and these were the kids. So Ben and Walter came and they co-taught my class, which was terrific. And then we had to figure out, during the pandemic, we wanted to do robotics from a distance. So we worked and worked and worked, and this is the solution we came up with. We wanted to create a special robot in which you could stick your cell phone into and then turn your cell phone into a Zoom substation, so to speak. So now we have a robot that takes our cell phone, that puts the robot onto Zoom, and then it looks like this, and then it ends up in an arena like that. So that means if I have one arena in Long Beach and the other arena in Ontario, that the kids could run the robots from the two different arenas over Zoom from a distance. We perfected this, and we are going to launch this thing in about 30 days. So it looks like this. So instead of the name underneath saying Bob Barboza, it says things like the rover driver, the telemetry that's coming off of the robot, who's the navigator, and all of that sort of thing. Who's the mission geologist? So all those kids can play those roles from a distance. And then you can see me over there in the corner at mission control. And then we take these kids on these science missions. So we created this incredible arena that we could put inside of the 50,000 square foot hangar. It's bigger than this classroom right here. And all the robots are down there, and all of you guys are sitting there running the robots from where you're sitting right now. And I'm taking you on a Mars mission. So we got an authentic Mars map on the floor, and you're going along, doing all kinds of things. Here's a kind of an example. You see a kid in there. So we've got various sizes. Because I have that 50,000 square foot hangar, we can really get creative. So, you got one computer running Zoom and the other computer running a robot. And then we've got a little bit of code that the kids can put in to operate all of this. I'll just keep this moving here. And then we do science experiments, and at the end, the kids write a report. And then they stand up and explain what they did, how they did it, and all that. So we're trying to make the robot programs culminate into a written report at the end. So these were some of the early stages of doing all of this. Of course, we were following all of the Mars projects and trying to simulate all of that. The software that we have generates this beautiful program where pictures of you end up on Mars, and you get to print that out at the end. So when we have more time, I can circle back with stuff like that. So it's all based on this idea, the first school on Mars. If we were to go on Mars, would robots be our teachers? And that sort of stuff. Because if, we were missing a couple of teachers like we are today, we're in a horrendous situation today. If you're a school teacher and you're teaching language arts in the afternoon, and then the principal says, hey, would you mind taking those other 30 kids? Because we're short 2 more teachers. So we've divided up all of the kids. So instead of you having 30 kids, you got 90. And so how the teachers are surviving all of that, it's time for robots right now, believe me. So when we started this project, we had help from all kinds of different engineers, and we were looking at nature. How could nature influence the design of robots and stuff like that? And then, of course, we were trying to take full advantage of that. We had a lot of nows, and we had a pepper right here at Cal State Long Beach. So we were doing that work, and then we got a request from SpaceX. Early in my career, I was involved in the military, in communications, and then military, and cybersecurity, and cryptology was my specialty. So the request came out, what do we do with these electronic cars if the Russians decide to punch into this network and take control of this car? Well, you're in the back seat when it happened. So what do we do? I mean, this is, we're really talking some serious security. So they found me and they asked me what I was doing in the military. And I said, well, I was doing certain things in the military that were top secret, but I'm doing Pandora 27 right now. And you're going to need Pandora 27 and about 27 other Pandora 27s to put up a network that the Russians will not penetrate. So, well, how will that work? Well, it'll work where Pandora will be loaded on the special card that would be inside of each vehicle. Remember, this is only one of your keys. And then we would work on that technology to try to step that coding up. And we'd use a lot of calculus to make it really secretive. And then the codes would start to look like this as they started to get generated. And then they would start to morph, and then we'd have to come up with devices that would mix the codes up constantly and put us in a situation where lots of different elements would come into place. Well, believe it or not, they bought my hypothesis. And I said, I would like to deliver a lot of this through the visual recognition of humanoid robots. Because I've been doing some work on these humanoid robots, and we're starting to get them to be pretty independent. They'll be working in the area of artificial intelligence this year for the first time.
My name is Now. I'm a humanoid robot imagined and manufactured by Polygon Robotics.
So I have different variations and different models. That's why I kept the oldest model, the middle model, and the latest model. So I am more famous for robots dancing than anything else. So all that work that I did with cybersecurity went out the window once they discovered that I was the only guy that could teach a robot to dance like Michael Jackson. Of course, that superseded any other scientific work you could possibly ever get involved in your life when you started this. This was a mistake, but here's a tiny intro. Okay, let's keep moving on and get a little more scientific and serious. This business of going to Mars and be able to phone your medical results to the planet would be a good thing. So we're now starting to look at a lot of that. So, okay, so what do you do with high school kids? How do you get high school kids to keep moving, to stay interested, and get involved, and one day end up in this room with you, all of you? Well, it starts with things like this, and then it's going to work. Let's see if I'm lucky enough to touch it slightly. No. Well, that'll be for the next talk. Our kids got heavily involved in underwater robotics. And because we have Catalina Island in our backyard, and USC has a tremendous science facility there, our kids got really interested in monitoring plants growing in the ocean. So if you ever invite me back, that's another conversation. Let's see if we get lucky here. We're not. Okay. Okay, so NASA had a few ideas about robots, and it looked like this, and it was very expensive. And notice the cables are holding it up because it still can't walk. The most difficult thing you can do, you figured it out by now, is getting this robot to balance and walk. They're not all going to be like Michael Jackson, especially this guy. When I get this guy to dance like Michael Jackson, I'll send for you guys. Okay, so the proof in the pudding. This is from hanging around Alan. And so Alan was the first guy on the planet Earth that I know of that was able to 3D print a robot with a complete, perfect complexion. Everybody else was struggling in the complexion area, and Alan mastered it. Because you could rub your hand on the side of Alan's robot, and I'm telling you, he won the award. The best complexion using a 3D printer on a robot. So now the proof of the pudding is, would you trust your baby in the arms of one of Alan's robots? So I always did this, and Alan keeps shaking his head, even as the year is 2022, and he's shaking his head again. But I used to use this to say, when you get really confident with your robot design, this is the test. Just like you had that special test with the language, this is my test with robots. Do you trust your grandchildren in the arms of these robots? Okay, so our students had to have perfect handwriting, because I heard this message, and it said, why are we involved in cursive and handwriting and printing? We have computers. Why is that necessary? And teachers were giving outrageous arguments about why we should forget about cursive and printing handwriting. So I said, I need cursive and printing handwriting because when you're on the planet Mars and all the communication equipment breaks down and it takes 20 minutes to send a message from Earth to Mars, you might want to hold up some perfect handwriting and say, please give me the code. I have 45 minutes worth of oxygen left. You might want to hold that message up. I told that story to high school kids, and you should see the handwriting that my high school kids are producing. And that's an example of it right there. You could read it from your seat. So here we go, bunch of kids trying to get them involved in robotics and probes and trying to get them to think about what kind of homes might we design for the planet Mars? And if we were to use our geometry in our geometry class, could we construct things on the planet Mars using the, NASA wants us to use the materials that are already there as much as we can. So we're thinking about that. We're saying, well, what about a 3D printer that can print ice? We got ice up there. What if we did that? So we started exploring that, and then it led to a lot of these tools. We need these little portable laser engravers and laser cutters, and we need smaller models of them so we could do experiments. So we started doing that.
Anytime you're ready.
So now our class has 30 of these on the way, and we'll be cutting our materials and building this and that using smaller, more inexpensive portable devices. And as time goes on, if you want me to come back in the future with these items, I can do that. But I'll keep moving here. And so if your handwriting is terrible, then of course we have the robotic handwriting devices that can put out a message in a pretty powerful way and beautiful handwriting. So we got all of that going. Let's see, that's what that looks like. So all of these devices are here, and now look at that handwriting now. And look at the other design work that you might be doing as you start to work with these robots. So the robots that are in my personal portfolio are what you're going to about to see right now. So my job is to come up with the initial design, and then of course get others to build it and worry about the language and all the other things. But these are kind of different examples of the things that are running around in my head. So if you could think of School of the Future type things, robots populating Mars, what might they look like? So all of the things that could pop up in my imagination, oscilloscopes that are smaller and mounted on other types of robots. And then of course, I'm fascinated with 3D printers that can print metal. And I had a good dose of that just recently. There's some of the metal that we could use, and because of the asteroids dropping all over Mars in meteors. And I'll go through this quickly. And then to be able to use design engineering to help us with the extreme radiation that we'd be involved in. So I'll go through this. I got one eye on the clock trying to keep you guys on the lunch break, just right on time. And then there's this. At the end of each arm of every robot, what could we design that could be controlled by the robot so we could do some of the emergency medical stuff that might occur on a Mars mission? Takes us 8 months to get to Mars. Things could happen along the way. So kids were doing all kinds of experiments on all kinds of different combinations of things that we might want to explore and come up with. So we got a lot of that kind of work going on. A lot of things were inspired by Maven and the different projects where we were probing underneath the soil on Mars for the first time. So kids were coming up with their version of what that would look like. That's where these things come in. I have to do a lot of work with getting kids to be creative and use their imagination a lot. One of the things that made America so great was we were so creative. At one time, we were the kings of jazz. We invented the music. We were good at it. Don't take that attitude to Europe today. Those European musicians will blow your mind. So we're starting to lose our edge in the creativity department, and I'm concerned about that. Because it influences the work you guys are doing when you're trying to work with robots at the level that you're working at, or a lot of the experiments. So here's Walter Martinez right there in the early days. We were barnstorming the colleges, trying to spread the word because there was a shortage of electrical engineers at that time when we first went out. And then we discovered that now there's a shortage of mechanical engineers, and it keeps changing. And I think we're in a little trouble in the engineering department because there's a shortage all the way around. So the pilots were telling me about the tremendous shortage of pilots we have. It's affecting you right now. I've been at LAX where the chief pilot walks in a room and he looks on a board like that where it says go beach, and he says cancel all those flights right there. And then they spend the day with the cancellation process. That's what's going on right now. Takes about 16 people to be around your airplane before it takes off. So here's the stuff that we were working on. We took a lot of pride in putting all of these kids in uniforms and designing other uniforms. And we came up with this. This is the smartest thing we ever did. We were in Riverside and we were dying in those uniforms. So we came up with this uniform and we said, oh my God, there is a God. All I need is this hat and that vest and I'm in uniform. Other than that, I was in a flight suit like this, in astronaut suits. So we ended up doing that. If you ever come to visit me, I'm drowning in airplanes. So to me, airplanes are robots. So I'm on this, and the supersonic flights will be controlled by robots. That's another whole lecture. So we're working with people from around the world. This is the Republic of Cabo Verde. So I had a chance to go there. I lost my good friend in Russia. This is Anastasia Stepanova. I had been working with her for 3 years. She's an expert in designing female bathrooms. All the women had to use the men's room, no matter if they were on the International Space Station or the rocket or whatever. So she pioneered that work. And then, of course, she was an expert at growing plants for Mars missions. And then I took over that. If any of you have been to my home, you know that I have hydroponic, robotic agricultural gardens, and we ate from these gardens during the pandemic. Let's see if I can go back here. No, we only got one of them there. Then I got, of course, interested in everything electronic for electronic cars. And I did a lot of work with that. I have a special presentation on just about every electronic car and what's going on. And then these are new materials that we're bringing in for additive manufacturing. Who knows who that short guy is up there? Well, he could have been the first person on the moon. That is Ed Dwight. And Ed Dwight was chosen by President JFK to be the first African-American astronaut. He thought during the time that might be a good thing to do, might help him get some votes in the African-American community. So that was kind of the thinking. And then after the assassination of JFK, Ed Dwight disappeared, but he's still alive. He's about 89 years old, and he is the oldest astronaut still living. And so I had a chance, of course, to teach Ed Dwight about the Now robot. So that goes on my resume. I taught Ed Dwight about robots, but he taught all of us about being a test pilot, and Buzz Aldrin took his place. If Ed Dwight and Kennedy had not been assassinated, this guy would have been the first man on the moon, and Buzz Aldrin would have missed that trip. So here are our people. The closest we get to Mars is every December, we were sending a group to Antarctica to do science experiments. So Stanford University created the science experiment, and then a National Geographic explorer led this team. And of course, we didn't have this beautiful device at that time. But this is the underwater device that our kids did in San Diego. It's our San Diego Tiger Team. And of course, this is one that I learned about right here at our club when one of our members walked in and he said, "Oh, you want rovers?" And then he showed me this and blew my mind. And then, of course, this is what's going on Mars right now. So what we try to do is create a little space simulator and to see how close we could come to simulating that kind of stuff. Let's see if we get this deep space model will trigger. Yeah. So we wanted to experiment with how could we create a deep space experiment using design, using geometry, using art. Then we had to design software for the projects.
Perfect. Now do the switch behind it.
And then
These them out of order. There you go. Perfect. Now go back to the right. Go to the right. Yeah, perfect. Go to the right. Right side down. All right. Battery switch now.
This is in my garage during the
Battery
pandemic.
switch. Flip that all the way forward. Perfect. Yeah, great. Now what you're going to do is you're going to grab that yellow disc. That's going to be your brake lever. So grab it. Grab it. Grab it like you're making a fist. All right, wait, keep going, grab it. There we go, all the way. Now, right hand on the joystick. Perfect, grab it with the right hand. All right, now throttle forward. Left hand on the throttle, look down, left hand on the throttle, grab the throttle, grab it and push it all the way forward. Grab it and push it all the way forward, all the way, and pull up.
Okay, all I can say is my last 3 flights have been crashes. So I have more work to do on the flight simulators. So coming from the Robotics Society to the Aviation Society is a little bit of a curve. Because we're real good at doing stuff like this.
Oh my God.
We thought we were going to raise some revenue during the pandemic at the malls. So we put the space simulator and flight simulator at the mall. We were charging $5 for a person to ride for about 5 minutes or so. And then we were using the funding from that to create these free fellowships so kids could take these programs for free. So what happened is when we were at the mall would open and close and open and close and open and close, and then we finally gave up.
Each of those scenarios, each of those elements, it's all there. We have all the data, we have everything we want to be able to do it. A lot of times the free but it's just about integrating it into here. That's kind of
Okay, so we had to keep going back to NASA and letting them know that we're serious about doing this and that we should have a kids tiger team because kids could do some serious work and they could do some serious thinking. So they said, okay, here's a challenge. We're going to go to the moon Europa, 26 miles under the ice. There's flowing water there. We want a water sample and bring that back to Earth. Can you prototype that? We said, sure. We were saying sure to everything that they asked. So we said, we can do that. Here's how we would do it. We would design a school of robots as if they were fish. They would be able to go under the water, navigate, get that water sample, and return it back to Earth. This is what it would look like. Okay, in the interest of time, I got to keep moving. I got one eye on the clock. All right, podcasting. for advertising purposes. Oh, that ain't gonna work. You don't get to see that. Maybe? No? Maybe.
You are listening to Kids Talk Radio. We bring you the news that you can use. We are reaching out to kids all over the world. You can find us at www.kidstalkradio.la.com.
Okay, we are looking for people that could help us with that level of animation. So if anybody knows about that anywhere out there in cyber world out there, that's something we're looking for. Okay, I'm gonna keep moving here and I'll go quickly just to say, oh, this was interesting. When the pandemic hit, it was up in January, I got a call from Boeing and they said, we're about to cancel our high school internship program that we ran for 50 years. Do you have any creative ideas? I said, here's a creative idea. Why don't we do the whole thing on Zoom? Have no one show up at Boeing. Forget about your old ideas about having a kid sit next to an engineer. Those days are over. We can't do that. Let's see if we can do the whole thing online. And lo and behold, they listened to me and we did it. So we ran it, but so they didn't have to cancel the program. So the little team I was on had 3 terrific Boeing engineers, myself, and about 8 kids. And so that was our team. And there were other teams. They broke everything up into teams of 10, I think. And so our team was to design the first coronavirus mask that would work for the airlines, that would drop down from the ceiling, that would help you with, that's what our kids came up with. So they ended up designing it as part of the project. And these are all of the other little projects that we did. We were able to get everybody a t-shirt because United Airlines was our new sponsor. So we could get things like that, have events, design projects. This is my little stint with the electronic cards. This is the short version, the different ones that are out there. And I'm just trying to go through here quickly. There's a picture of 1,000 words. I don't need to say anything. We're also interested in robotic design and satellite design. There are some of the ideas that we were experimenting. Okay, it is exactly 12 noon. Because I'm a board member, I gotta follow this here. Okay, ladies and gentlemen, thank you for allowing me to come in here and out there in the internet world, you guys that are out there. It's good to be back. This is the second time I've been back since the pandemic. I've been working from home. Got a lot of work done during that pandemic period of time. I was basically locked in. But now that I'm out, now that I'm released, if any of this interests anyone in the club, it's easy to contact me because that BarbozaSpaceCenter.com has running updates of everything that I'm doing and all of the contact information is there. You just have to remember to spell Barboza with a Z and not an S. When it's with a Z, it's kind of like a Portuguese word. When it's an S, it's a Spanish word. But that Z and S was causing havoc all over the place. Kids Talk Radio goes out to almost 500,000 people. There is a Kids Talk Radio Russia, which we haven't used in a long time, which is sad because we've got people there that were working with us on a regular basis.
You have a question online?
Yes.
Les is asking, have you thought of a space junk capture green satellite?
Yeah, as a matter of fact, what happened is we received an intense lecture on all of the space junk that's out there. And the request did come in for a design. So the first design that came in was a satellite to repair other satellites. And this was a project that I believe was going to be initiated by Northrop Grumman. They gave up on the project, but we got to get the project book. So when we got the project book, we got to see exactly what was involved. and you coming up with a design that you would submit to Northrop Grumman or Boeing. So the second request that came in was, the exact request you're talking about was a satellite to help collect the junk. And so because I'm on the robotics side of things, I stepped away from that particular project, but I'd be willing to search online because I remember the people that were doing the project. Any other questions? Okay, well, I want to thank everybody. It's lunchtime, and I turn the floor back over to Alan.
All right, thanks, Alan.
Well, we got a question. One of these days, can we get a tour of your Ontario hangar?
Yeah, you know, I'm glad you brought that up. Remember when we used to have the robot showcases? And you did at least 2 of them, but as a collective group, we did 3. I was thinking of combining a robot showcase at my location, and then I would take everyone on a tour. We could make it be a part of it, or you could come a day before or a day after. But we were sitting down saying, rather than totally give up on robot showcases, that maybe we try one at my place. So that's, Thomas, that's something for you to think about. You got my contact information, and I'd be happy to entertain a tour for the entire club.
Yeah, that'd be great. We'd love to see your facility up there. That's Ontario, right?
Yeah, it's and I'm in the administration building, and right next door is the 50,000 square foot hangar, and all of my classrooms are in the parking. We have the best parking in the world. It's free. Don't try that at LAX. I went to LAX and I attended a meeting that lasted 30 minutes. And I think they were charging $1 a minute because my parking fee was about $35. That will not even when you come to see me. I promise you that.
How often do you get out to Ontario?
How often do you go to Ontario?
Oh, I was driving from Long Beach to Ontario once a week, every Saturday. I only taught school 1 day a week. So I would get to work in my Long Beach office during the week on projects like this, and then go to Ontario to practice what we were building or designing. So once a week I'm there. But you know, if the club wanted to do something special, I could, you know, I could say, okay, we'll go on Wednesday. I'll get the keys. I'll open everything up.
Oh, we're more weekend people. We're all working midweek.
Yeah.
Most of us are weekend. Some of us are retired, but not a lot of us.
Well, you know, that's something the club should talk about. We might do a Sunday. You know, where you have your regular meeting, and maybe you come down on a Sunday with neutral day. So, okay.
One more question.
Sure. Question?
Yeah, with I noticed, you know, all the different robotic projects you showcase, and some look fairly sophisticated, others might be off the shelf. I'm just wondering, do you have, and some you've created, do you have an engineering people that are kind of helping to design these robots and all that electronics and hardware?
Yeah. You all, everybody in this room knows that you cannot create all that by yourself. What we did is we started working with Tiger Team. So you'd have a Tiger Team of people that were interested in, how do you make a robot that works over Zoom? That would be a Tiger Team. And then I would work with that team because, of course, the reason they're doing that is so we could use those things in the classroom.
Are those volunteer or hired, or?
Some of them are volunteers, and some of them are creating commercial projects, like our laser cutters and our laser engravers, and all of those types of devices are actually made in China. And we have a relationship with the people in China, so we could use them in the classroom and use them to help promote scholarships. Yeah. So of course, China was hurt really badly with this pandemic thing. you know, you put in an order now to be delivered, not this Christmas, next Christmas. So we're still, you know, you just look out at the port of Long Beach and you can see what ship your merchandise is on. So,
Is that backlog lowering?
All right, so thank you, Bob.
okay.
All right, we're officially on lunch. We'll probably come back at 12:45 for the business meeting.
Yes, I went searching and I found out about the SLIP language. This program was originally programmed in a language called SLIP. SLIP is a list processing computer programming language invented in the 1960s. It stands for Symbolic List Processing. Not to be confused with Lisp, which is a similar language in theory, not in application. So I got a copy of what was the original code. Let's see, is this it? No, that's not it. No, that's not it either. There it is. Okay, so this is a copy of the original code. The real original is lost, it says here. This was from 1966. It was called Eliza, a computer program for the study of natural language communication between man and machine. And they tell you a little bit about this programming language and how it works. I'm not going to go into that. And there's some sample code there. This is the mad slip. And there's the actual code here. Please don't apologize. And it goes on and on and on. Do you think it's likely that? Do you wish that? And this just goes on and on for lots and lots of pages here. And then somebody decided, well, we can do that. And that was a programming language and compiler, et cetera, that was dead at the time. So you couldn't really run this anywhere up to I don't know if you can run it anywhere, but you probably can if you put enough effort into it. And then somebody came up with the basic version. And this is the basic version. And this is horrible, absolutely horrible. It has.
Is that a Word file?
Yeah, I put it into Word. I copied it all into Word to make it easy. And so the color input, that's my changes. I was trying to reverse engineer it. So basically there's the user input section, the find keywords, the take a part of the string and conjugate it. And then the data follows. And it's just lines and lines of data statements. If you're familiar with BASIC. So I said, okay, this is fairly easy. And, you know, it's just a whole bunch of go-tos and, you know, go to here, you know, go to 200. Well, that's easy enough. And then, of course, I decided, well, since I'm doing this, I might as well try to translate it. And so I tried to translate it into Python. Last night, I just started this last night. This is as far as I've gotten. Prints were real easy. I figured out how to clear the screen. And then I said, well, you really don't need to read things in. You could read things in from the external file, but I just made lists here. So this is effectively reading in this data so we can access it. And then it did some numerical computations, and then I just did that manually and got my input to work, and that's as far as I've gotten. Any questions before we move on?
No, good job. I remember this is one of the first programs I ever ran in elementary school on a Model 33 teletype connected to a PDP-11 thing. Think of it. In BASIC.
In basic, yeah, those go-tos are hard to transcribe into, methods. It's just,
You shouldn't change it to go subs. Well, 'cause like go subroutine, or just assume that they meant go subroutine, so. And then there'll be another that's a return, essentially there'll be one after 4:30 that says return, that's really a return. But yeah, if they should use go subs, they had go subs back then, I thought.
yeah,
Maybe
they
that was
didn't use go-tos, it's all go-tos. Like to exit, there's your loop exit, go to 250. And if this happens or that happens, you exit the loop. That's the main loop there, the input. And there's the, if the input is the same as before, then please don't repeat yourself. And then then you look for the keywords. Then you swap the English. And I'm still looking into it. That's about it. That's all I have. I didn't take up my 10 minutes, probably 2 or 3 minutes. So thanks.
Thank you, Thomas.
Yeah, please,
Good luck with that.
yeah, please
show us.
share that when you're
Yeah.
done, on a GitHub or something.
Sure. Yeah, I'll share it when I'm done. It's a great exercise because, I learned Python a few months ago. And well, I learned Python a few years ago, but I was never proficient at it. So this helps me in my proficiency because I'm figuring out all sorts of things I would never have done because I need to.
All right. Good luck with that. Looking good.
Thank you.
All right. Next, Alan.
All right, so I'm going to do 2 things. I do want to give you guys an update on GPU pricing because I think it's terribly interesting and exciting. But before I do that, I wanted to see how well the large language model does as an Eliza. So we've got a quick context. I'm helpful, I listen, I'm awesome. What do you want to talk about? Sometimes when my alarm goes off in the morning, it makes me feel sad. I just wanted to run this in front of you guys live to see how well it would do. Oh, all right. So we asked for so many tokens. I don't want it to answer my own questions. We're going to erase that. Like we came up. We'll just give it 1 or 2 more chances, then we'll go on. Okay, apparently I'm depressed. Fine, I'll take it. So on the GPU side of things, so the last time this happened, NVIDIA was caught off guard and they actually got sued for being not as honest as they should have been with their quarterly earnings report about their sources of income. This time around, 3 or 4 years later, they've been smarter about it. They knew that there was going to be a crypto crash and they planned ahead by using a different process node and giving the cards some more power. The next generation cards are supposed to be 50 to 100% faster than the current ones. So like, hey, we'll beat the rush. We know there's going to be a huge influx of used cards, but our value proposition is, why would you buy a used card for cheap when you could buy a new card that's twice as fast for expensive? I almost thought they had it cornered. That was great, but they did miss something. First off, in terms of the prices for new and used cards, they are now approaching the MSRP that the cards were supposed to have been sold at when they were released. And although that is cause for celebration because, they've dropped in value by 75% in some cases, there is a large and vocal group of people who say, hey, when's the last time you spent full MSRP for a 2-year-old card, the card that's been out for 2 years? So I think values and the prices are going to continue to drop a bit. At the end of the day, if you need a card, you buy the card at whatever the price is. And the prices are better than they've been in 2 years. But there's one thing that they didn't take into account was maybe when this flood was going to occur. Because store shelves are packed with new RTX graphics cards. And no one's buying them because you can buy them still for half, 2/3 of the price on the used market. So good news, there's lots of cards available, but for someone like me who is looking forward to buying the next generation of cards, the resellers have talked NVIDIA into postponing the release of the new cards because they want to get the old stock out of the way.
Oh,
So it's sitting on short store shelves. It's a lot of potential revenue. I think retail prices on new cards are going to continue to drop, hopefully to where they should have been had none of this happened. So if you're the kind of person who's looking for an amazing deal and don't think it's here yet, wait a little while longer and see what happens. But if you were waiting for a new RTX 4000 graphics card, they're probably not going to be released this year anymore. So that's your latest update for GPU prices in retail.
Thank you. Jim, you're up.
all right, let me, can you stall me for a second here, because I'm trying to get this set up for the start.
So, any plans on selling yours?
Mine 4 were supposed to get into a deep learning machine, but the component shortage has made it so I can't buy the motherboard and processor that I needed to fit them all in the same box. So I'm not sure yet, but you can find 3090s for like $900 sometimes now.
3090s?
Yeah,
That's what I want. And that's with the 24 gig or?
yeah, retail, I think they've dropped to 14 to 11, but I've seen a couple of YouTubers that are claiming they picked one up on eBay for like $900.
Okay,
So
that's a bargain. That's a real bargain.
yeah, the extra memory is super helpful for some deep learning stuff.
Yeah, for the deep learning. I mean, yeah, and that's likely to stay that way for a while until that stock is.
Yeah.
It's just a sec. Yeah, okay, let's go. All right. I am ready. All right, so yeah, thank you for allowing me your time. I'm going to do a couple of things. First, well, one is I've added, been in the process of adding this millimeter or a 24 gigahertz millimeter wave radar to Big Orange, and to detect people, basically movement of people. There's a few different products available through Seed Studio, and this is the sort of lineup. 24 gigahertz sensor, human stationary and movement. 60 gigahertz sensor, human resting. The one I got was this one, the 24 gigahertz sensor fall detection module. Unfortunately, I found out after buying it, the fall detection mode only works when it's mounted overhead. It's for like in a shower or some kind of, bathroom or whatever, or a facility for people that, might have a fall, and this detects, but it only works from above. But you can also use it to, in other configurations, like direct line, to detect people movement and essentially movement. But they have all these categories called heartbeat and environment, and I'm trying to figure out what the data actually means, but they release these other ones that are more, they claim are more geared or aimed at actually determining heartbeat, like actually determining respiration rate, at least, things like that. But mine is supposedly can detect a person resting versus a person moving versus no person. That's kind of what it can do, and that's what I'm trying to experiment with, and I'll show you that. So that this is the lineup of them, and the one I have is this one here, the fall detection, and that's the radar right there. What's also cool, now I already have a nice AI visual camera that can detect people, but this thing can detect people without that vision being on at all, and it sends messages. This runs on the Arduino portion of runs off an Arduino, and the radar can go through light barriers such as partitions, but not full walls, but maybe doors, and certainly like light type of barriers, like a shower curtain or maybe I don't know if or something like that. And I tested it at home. I was going to bring in a big cardboard box, but I didn't bother. So maybe next time, but I tried it, and it through like a cardboard box barrier, it reacted to my movement. So that in itself is beyond what a visual camera can do. And the applications for that, I'm not 100% sure, other than the safety thing, like someone's fallen in the shower, it's a text. There's no movement there anymore. Although behind it, there's some interesting applications you might do. That it can go through barriers, okay, let's move on to the that's that, and this is the other side.
So Jim, did you say that uses radar?
Yeah, so this is using radar, 24 gigahertz millimeter wave radar,
and it has software on board, I guess.
It's what?
It has software on board that it puts out and gives you information.
Yeah, so this works, and I'll show you what I did. You run software on your Arduino. It has a library, and then you get messages back from it. And I guess I can just jump to that now. I've got it running. And here you can just, I guess, to speed things up, I can do stuff later. I can do more later, but this is the live output from it. I've got it pointed away from everybody. So now I'm moving into its range, and you see it's gone up to 97. So I've written this code to type out this message. The message they initially had was sort of not translated well from Chinese, but it was okay. But so what I've done now is I'm getting all the data, or it's like some bytes get sent across a serial port to you, and then these different codes have different meanings. And so I listed it out. Report type, I call it the body sense, and then the number you see is the speed of what it thinks is moving. And then you also have another thing called heartbeat as the report type can be like radar, and then it might say or other, and then heartbeat. And the heartbeat is just either body moving or body at rest. So these are there's what's going on is the raw data from the radar is being interpreted by firmware code they wrote, and it's sending you back a kind of high level interpretation. You don't have access to the real low level data, but you do have access to a bunch of these codes coming across. And that's sort of then you can interpret. And there's a few of them, and I'm not sure what they all mean. So I'm trying to figure it out so I can then end up doing something reasonable. So like here, it's pretty much like nobody's there, because it says, now it's nobody. It does take a little bit of time to stabilize. And I think even if I move behind it, it might, see, it's the radar may even detect the opposite direction behind it, because it's kind of permeates in both directions. So this I could use for orange to detect if there's a person in the room or comes in the room, because usually it'll be like nobody present, and then you know, somebody's definitely moving, and then I'm close or away, the closer away, I think it works okay. It just needs more testing. But, and then if you're sitting down resting, it knows there's something moving a little bit. And so then the orange would know, oh, hey, someone's in the room. Maybe I could talk to them like, hey, Jim, what's going on? And otherwise, if nobody's in the room, it won't try to engage. So it gives a little bit more, I'm hoping this would give some awareness to the robot of who's in the room, what, you know, if there's a person in the room or not, and if they're moving. And that could be good for security and other you know, reasons as well. But I wanted to get a little into the background of how this is done, because the way I sort of the nuts and bolts is what I've been spending most of the time on, which is getting, first of all, working on an Arduino was very easy, just plug this thing in, but to get it working on my robot, I don't have an Arduino separately, not yet. I mean, I just don't need one. I have what's called the Latte Panda. The Latte Panda is a PC, but full, you know, single board computer. But it comes with, what's cool about it is it comes with a built-in Leonardo, Arduino Leonardo. And so here's the board, and this is the pinout. And so the Leonardo portion of this is the Latte Panda, and this is the Leonardo portion. So what's cool is this microcontroller is built into this single board Windows computer, and you can talk to it over serial port. And so what I gotten into, which is what shipped with it, is this thing called Fermata. I don't know if anybody's heard of it, but Fermata, and specifically PyFermata, is a way used to use Python to now what Fermata is specifically for Arduino. Fermata works on multiple hardwares, but Fermata is a protocol for communication with microcontrollers from software on a host computer. So since all my code is in Python, it'd be really nice to just write all the microcontroller code in access in Python, which I already do for the servo motors that control the camera. And Fermata is this protocol that instead of writing your own serial protocol yourself and flashing it to the microcontroller and interpreting it on the other side, this is a system that gives you some functionality without much effort. So I'm adding the radar to the Fermata, and that's been right now it's broken the servo. The servos are kind of funky right now because I didn't quite. It's not quite right the way I'm doing it. But Fermata basically it has a framework for sending messages over the serial port. And so you can then add messages and that sort of thing. The way this millimeter radar works is it uses soft serial. This is the first time I've heard of this. Software serial uses some other pins, some compatible pins of your Arduino, and it turns that into serial. So I've got this millimeter radar talks serial to pins 9 and 10 and 11, and then the information from that gets sent to the host computer over the normal serial port, the regular COM6 or whatever so there's actually two serial interactions going on. So that's what's kind of interesting about this system, that it does that, and it's a little bit of a challenge for this, like I said, the PyFermata have to update it. And there is a version that is called Serial Pi or Fermata Serial, so I'll be using that one. Anyway, any other questions? Are any questions about that?
Have you tried any of the Texas Instruments development kits yet. They're more general purpose. So you get the low level hardware access rather than the high level.
For the radar.
Mhm.
No, I haven't, sure, this is the first one I've ever used, so, I think I heard of Texas Instrument ones,
Yeah.
some other people using those. I didn't know anything about this, I guess I didn't read before buying it, was a click rather, it's $32, I
Yeah.
think, for, but, yeah, and it's easy to start playing with,
Yeah.
but it's a good entry radar, I guess, but yeah, the ones you're talking about maybe a better, more serious way to go. I had an update on, if there's no questions.
Yeah, Jim, I had a question before you move
Yeah,
on.
before anything.
I remember the day you bought that initial robot.
Yeah,
And so how much money did it take to get it to the state that it's in right now?
yeah, it's a fair amount. It's like, well, it was I think it's under 2,000 perhaps, but it was $1,000 just for this frame and the LiDAR system, the slam check system. That was like 500. This was over 500. That's 1,000 off the bat. These things I have two of these cameras. One was free for me, but if you wanted to retail, each of the OPD cameras is, what is it, 300? Or it
I
was
think they came down in price.
200 or
Yeah.
200?
I think so.
So that's 400. So that's, already now you're at 1,500, and a monitor, 1,600, battery, 1,700, other miscellaneous things, and you're probably 1,900.
So you have a Panda.
Still cheap. Oh yeah, the Panda, I'm sorry, I forgot about that one. Yeah, that brings it almost to 2,000, yeah, 1,900. Yeah, this is like, I have fewer computers on this than Dr. Bruce's. I have, because I don't like adding things. It's a lot of work. So I try to use everything that's there. Like Dr. Bruce's also has a Latte Panda, but his is an Alpha, which is, I guess, even more powerful. I got the Delta, which was designed for robot. It kind of came out later, but it has the built-in Arduino, so I don't have to add my own Arduino, at least start. And then I've got the SlamTech. Basically, that's got a Linux computer on it and a ESP32 ESP32 microcontroller, and that's like the main computers. And plus, there's a TPU card plugged in. But
Did I hear you say you had a Leonardo?
yeah, so the Leonardo is built into that Latte Panda.
Oh, so you got 3 processors on that Latte Panda?
Latte Panda has it's got an Intel Celeron type of processor. It's got an Intel processor, and it's got the Leonardo microcontroller, just the two.
Oh,
But then on the second level here, you've got the SlamTech Slamware Core, SlamTech breakout board, essentially. That has microcontroller STM32. It's STM32 microcontroller plus a Linux computer that's like on a card. It's a proprietary system for Slamware. So that's 2 microcontroller and another CPU on there. That all came together.
so how difficult was it integrating all of those pieces?
Well, the Slamware had lots of documents. The SlamTech system was designed to be bought and used in your creation. It was a reference product. So they had the infrastructure and instructions on how to readapt to a larger or different size robot. That's why Dr. Bruce, myself, Gary, Malepsy, and Alex, I forget his last name, but they all, and a few other people used the same device. John Davis used the same SlamTech mini robot and took it apart and repurposed it. So that part it's challenging but there was a lot of information already there to help you to get a motor controller, get some wheels. This particular orange thing, the HCR, had it's sort of a tutorial on bringing in the slam check. So I benefited from all that stuff. And then, more the later things I kind of added on, I keep adding on to, to the Windows, plugging into Windows machine, getting the 3D cameras, and the display plugs into the LaMDA Panda and battery stuff, all the other stuff you had to learn, and the new audio, a microphone array that plugs into Windows.
So what role did Dr. Bruce play in advancing you into the system?
Well, the idea of the slam tech, the slamware, a lot of that, the sort of the arrangement of the components in his robot. I went a slightly different path because of my particular hardware, but it was similar. He inspired that, and the software. He shared Python code with me, and that helped a lot, and that formed some of the basis of then I built on that code. And so I took his code and then adapted it and sort of wrote more and more on top of it, and rearranged things to my liking. But it was this was the best collaboration I've had here in this group, this club, because we shared able to share code, and the DLL, there's the Python to C conversion to the Slamware. Slamware has a whole API, and anyway, that was done by Gary Gillespie, I think it was either Gary or Alex. I think it was Alex's code, and both of them wrote, and that was kind of a bridge code. And then I took that and used that and added more commands to it, because the Slamware core was all in C++. Our main code is in Python. We wanted to use that from Python, or Dr. Bruce did, and then I did as a consequence, because I started loving Python too. Anyway, so yeah, I didn't need to go. I could talk give a whole talk on Orange, I guess, maybe someday. But it is, it's inspired by a lot of that Dr. Bruce's and Gary's work. And anything else? This is the board I showed you, the empty one, and I filled it up. And
oh, is that the one you designed?
Yeah, I designed this one from an old schematic from the 70s to fit in my Commodore PET 2001. I even forgot something and forgot a feature, and so it was easy to add a little jumper and a resistor on the backside. The next revision will have that in the board. And there's a video online now of me demonstrating that, and with the Commodore PET. But I guess I don't know. I think I've used up my time. But maybe I'll show you that next time. Or at the end of this, if anybody left. But yeah, this works on it, and it plays 4-voice music on the Commodore PET 2001, 1977 computer. And that was the only way you could play sound, was you had to add a board of some kind. The simplest way was to add a resistor and an amplifier, or a plug, so that you could plug in an amplifier. And I did that too. In fact, that's what this little addition is. That's called the CD2 sound, which is just 1-bit sound, where they use a shift register in the PET, and they could send it bytes of information and tell it to loop separately using this IO chip. It had a PIO chip. So the processor could still be playing a game, and the the PIO chip would push bits out to this one line that you would then amplify to a speaker. Then somebody came up with the idea, actually it this famous guy, that sort of a father of sampling music, wrote a Byte magazine article in 77 with the idea of a resistor ladder based digital to analog converter DAC, 8-bit DAC. It was one of the first for your Kim computer, for those who remember the Kim 1, which yeah, before my time, but that's what it was for. But it was for any 6502. You're certainly familiar with 6502, and it had assembly language, and it had a schematic for something pretty much the same as this, that you could play 4-voice music on a simple computer like that, using the I/O port, the 8-bit I/O port. And that one does not have an I/O chip running it. You have to use the full CPU. So when you're running this and playing this 4-voice music, that's all the computer's doing. So you can't use it in games. Whereas the other 1-bit music or music sounds, those can be used with games. So this board has 2 different types of audio output for that old computer, the 1-bit and the 8-bit. So yeah, and I actually, if you want to hear, I can quickly bring this up, which is kind of what the music sounds like. If this would ever, oh geez, everything's so slow. So here's like one of my favorite songs.
This is the 4-voice?
Yeah. Why is it bringing that up? Oh yeah, I can play the 1-voice stuff too, or one.
And that brings, is that like the Gambler?
This is called the Easy Winners. And you know, for a 77 computer to do that, it's no easy task. And I kind of went in deep into how it worked and the sampling, and it used 256 bytes of a sample of a kind of an organ wave, a wave. I got the wave into my PC and I could modify it and put it back onto the old hardware. But it was just a 4 or 6 milliseconds of a wave that went, that kind of the end of it ended where the other part began. So it formed this, and it wasn't just a sine wave, it's just like kind of a little more complicated.
So it formed a loop?
Yeah, it forms a loop. So in assembly language, this plays, and what was really cool about this is, for the way they get 4 voices, is each voice can only go from 0 to 63. And then you get 4 of them add up to no more than 255. And that's how they fit it in the 8-bit.
Gotcha. I remember that song was played in one of my old Atari ST games.
This one?
Yeah.
Oh, really?
That was one of the songs I remember.
Anyway, so yeah, that spent a month or more on working on all this old stuff, and I did learn a bit. It's definitely, there's some value to the hobby level of those old computers. Really was a teaching mechanism. You could learn a lot. It's even applicable today. I mean, if you don't know electronics, I mean, I wasn't trained, so. All right, thank you. And I'm off.
Thank you very much.
All right, that there's no more show and tell, so this will conclude the meeting. Good meeting, everybody. Thank you, everybody online for joining us. I think everybody left already.
Oh, did they?
Yeah. So see you guys next month.